Hello all. This video is all about MSP430 timer module in Introduction to Embedded System Design. So what is a timer? Why we have to use the timer is because timers are used specific like generating delays, baud rates, and also for counting the events in fixed intervals of time. A dedicated hardware timer frees up the processor so that it can perform more or non-time critical processes. So that is why we are making use of timers. Software delay loops are a waste of the processor's capabilities. Also, delays written in C language are not precise. So, a hardware timer. Why we are going for because of software delay, we are going for a hardware timer preferred inside a microcontroller. So that is the main reason. MSP430G2553 has a 16-bit timer A and timer 1, timer 0 and timer 1. So we are going to learn about the features of the timer in MSP430G2553. So timer A is a 16-bit counter with 4 operating modes. It can count till 65535. Timer A can be used to capture, compare the pulse width modulation signals. It can also be used to generate the interrupts which may be generated from the counter on overflow conditions or from any of the capture or compare registers. It can measure frequency or take time stamp of the external inputs directly. Outputs can be driven at specific times precisely, either one at a time periodically. So here is a block diagram of a timer. Here we have TA clock, which is nothing but the clock acknowledgement. A is a clock acknowledgement. SM clock, input clock we have, output clock we have, timer clock we have. Clear the signals, reset 16-bit timer we have, comparator to compare the bits, output unit, enable signals we have, and count mode we have. Capture mode and the synchronization signals are generated using timer A clock. So timer A major components are like timer A counter register TAR. This is a 16-bit register whose value increments or decrements with every rising edge of the clock signal. Behavior increment or decrement of TAR register can be selected by configuring the mode of the timer. So this is the timer A register, TAR register, which is nothing but the count of timer A. Timer A capture or the compare register. There are three capture compare registers in every timer: TA0 CCR0, TA0 CCR1, TA0 CCR2, TA1 CCR0 compared with CCR1 CCR2 for timer 1A. There are three channels to share the same with TAR. Capture versus compare mode. In capture mode, the timer value is captured in this TACCRX register in an external or internal input event. In compare mode, timer value TAR is compared with TACCRX register and operations are performed based on the compare event. The compare mode is used to generate PWM output signals or the interrupts at specific time intervals. Clock source for timer A can be sourced from ACLK, SMCLK, or externally by TACLK or in the clock source is selected with the help of TASSEL XPace. The selected clock source can be passed directly to the timer or it can be divided by 2, 4, or 8 using the IDX space. The timer clock divider is reset with TACLR is set. Timer mode. So we have 00 as one state, 01 next state, 10 as the third state, 11 as the fourth state. So in 00 we have stop mode, 01 we have up mode, 10 we have continuous mode, 11 is the up mode and the down mode. In 00 timer will be stopped, 01 timer repeatedly counts from 0 to value stored in TACCR0 register. In 10 what happens is like The timer repeatedly counts from 0 to 0 cross FFFF hexadecimal. In 1 1, the timer repeatedly counts from 0 to value stored in TACCRO and then back to 0. So these are the timer modes which we have in the embedded system. I hope you would have learned from the video. See you in the next video. Until then, it's bye from Radhika.